Hey, happy Sunday afternoon. Uh, Today, I'm going to be listening to one of my Desert Island discs, Earthling by David Bowie, and working on rendering some levels in the Summoning. So, as a reminder, the Summoning is a game that I played when I was no less than 10, I suppose. It came out in 1991. It was by Event Horizon. It's a pretty cool computer RPG, isometric view. And I have been working on reverse engineering a variety of different file formats in it for some time now. It is my not feeling amazing return to project. And so I've been working on that quite a lot lately. Um, Actually, that's not true. I was working on it a bit in December and then a little bit later. So um, today I have decided that I've had this I've been able to decipher the level maps for some time now, but what I haven't been able to do is actually get the isometric maps rendered. So today, that is going to be my task to see if I can finally pull it off. Okay, so I actually have a couple different diagrams. So what I've done, this is an Excalibur diagram that I came up with some time ago. Um, oh, right, I gotta switch my diagram. All right, I gotta switch my scene. So this is the introduction scene. You show up. Um, this right here is actually I think this might be from one of the demo files or something like that. It doesn't really matter. This is a teleporter, but you show up right here. You go over here. And what I did was I rendered what I think are the integers that represent each one. Now, actually rendering these things, I tried with Python image library and things like that. Um, what I ran into was that my rendering was kind of clumsy. I wasn't doing the best job. And so it was tough to decipher what was an error on my part and what was an actual error in my understanding. So pulling the implementation separately from the other. So what I've done, and we can take a look at this, is I've set up a couple different rendering methods. One of them, let's see, yeah, I guess I didn't do that. All right, examples. Yeah, so this is my attempt at rendering a couple of the levels. You see that I was able to get the walls, and they basically all look like them. But what I want to do, let's see, rich pixels. Yeah, I think that's the one I want. Right, I upgraded my conda environment before since then. So let me go ahead and just install. We'll install with pip. Now, while it's doing that, let me Oh, looks like it did it. Oh, right, that wasn't it. I did figure out how to get the sprites to display, but let's see, render levels. Is this the one? So I was experimenting with Textual for a while. It's a pretty rad library. Oh no, that didn't do it. That just dumped it out. All right, level. It must be level viewer.py because it's got a CSS file associated with it. Yeah, here we go. So this is what the levels all look like. If I shrink this, you can see them a little bit better. Now this map, if I remember correctly, did I use CP137 in this? I can't remember, but basically these are all the different levels. Oh, CP437. Yeah, I think I used CP437 in this. So that's code page 437. It's it reminds me, here, let me put myself over here. The reason that I liked using it was because it was a little reminiscent of Craws, which was a fun game that I played once upon a time. This, though, is our initial level, and that's important. So, what we're going to do, is here, let's see, let's load up DOSBox, and I'll give you a shot at what it looks like. Assuming that it works, it very well might not. I forget how I launched DOSBox last time. Oh, there we go. It's doing it. Let's see. DOSBox doesn't want to load up. That's odd. But it probably will any second now. So we'll give that a second. There we go. All right, CD the summoning. Now I have not cracked this game, so that means when I load it up here, I'm gonna have to load up my manual over here. Now on my blog, a little bit over a year ago, I talk about how there we go. Let's put that right there. I talk about how I was able to reverse engineer the algorithm that it uses to compute the copy protection. It's a pretty clever little thing. It avoids having any copy protection values right there in the data files, and so it makes it a bit harder to. It would have made it a lot harder to crack back in the day. But I own this game. I purchased it at least 3 times now. Let's see, page 56. Now I'm not going to show page 56. Let's see, that should be 23. Yeah, there we go. Page 56. We go with Larry David, Hood Person, Cool Feather, the chainmail, and then guy with Rev. Okay, so now I'm going to select a character just so that we can go in quickly, and I'm going to demonstrate for you. Notice here, this is not isometric, of course. This is XY coordinates. The way isometric rendering, as far as I can tell, happens inside games like this is that they store the maps, of course, as XY, and then they draw them in a pass across this way by iterating over the tiles in the correct order. So, the mapping between screen coordinates given a bound on the screen and an XY inside the, or a mapping between the screen coordinates given bounds, XY bounds, or rather pixel X, pixel Y bounds, and the tiles that are drawn from is the part that we're going to be experimenting with here. Now, there's a second component to that, which you'll see as we get in here. I'm going to start the game, and then I will pause it right away. Now, the way these graphics are done is really cool and clever and whatnot. I actually learned recently about the way that DOS games could split the screen into different regions for refresh, and the summoning does do that. It refreshes the bottom and the top independently. Now I'm going to pause this. Let's see where. Here, I will take a screenshot, but there's a way to do this. Pause emulation. So here we are down here at the start. Okay, now inside the levels there are codes for where the character can start. If they start on a level, there are also entry and exit areas and whatnot, and all of that stuff is contained inside a file called levels. Now I'm going to start a new terminal, and this one will be higher text resolution. And we'll take a look. Dev dispersing. We'll look at the KSY files and we'll look at level. So the way that it's stored is on each level. So there's a header at the start of the file, and then each level is consisted of item data as well as tile info. So type level is a sequence of integer for height, integer for width, a set of level properties, which I have not fully decoded. There's a whole bunch of unknown stuff in here, although the unknown stuff is not necessarily operative. But it includes things like links to the tile offsets and the sprites, as well as the gate tiles and the sprites and whatnot. Following the level properties, there's a map, which is always of size, width versus height. And that map is one character, or rather 1 byte for each tile, or entry. It has, I believe, 255 wherever there is nothing. And then we'll talk about the other stuff in just a second. Then there are items, and this is a repeat until the item listed is 255. Or rather, the way that the items work is it is a type item data where item data starts with the X and Y coordinates, and then there's an info assuming that they are not 255. So finally, we've got a bunch of speech strings. These are just null delimited speech strings that are keyed earlier on. You'll note that they have size. Oh, they aren't null delimited. They're size delimited. And then sometimes there's other data, which is typically things like procedures. So, like for instance, if there are opcodes that key to different procedures, I was able to decode most, but not all of these, I think. Yeah, type procedure, sequence the opcode, and then we've got a set of opcodes here. So here are the different tile flags, so for inside a tile, and then here are the different procedure opcodes. All right, so let's go back up here. The key thing that we need to do is given a value for a tile. So these values might be bit encoded. They might have, they might have different bit fields embedded in them. Oh, I missed looking for satellites completely. I'm going to skip back because looking for satellites has just the most amazing guitar solo by Reeves Gabrels. You should look up the story of it. He was given a really constrained set of parameters for his guitar chord changes. So anyway, you should check it out. I'm going to listen to it again. So let's take a look at our levels. This is our first level. And you'll note here's where our player starts. This is where our NPC is, and then we've got our floors here. This is what I want to look at it in. Okay, for this. So if I unpause emulation, let's see, I think that was Alt F12. Huh. Did I kill DOSBox? Oh no. DOSBox got very confused. Possibly because I left it sit for so long. Alright, let's close that. Yeah, I broke DOSBox. Here we go, pause emulation. Alright, so at this point we're down here. This is over here. Now I'll use the mouse. Got our character walking. This is where a teleporter shows up. If we say the right code word, there's our talking skull, which you'll see right there. The portal is not for the meek. That's actually referring to the door, not the so-called portal, the teleport portal. If we go down here, This is where a key piece of information we can grab is. So this is 1 unit. That's right there. This is 1 unit. That's right there. But if we take a screenshot and we look at this, of course this looks like more than one tile, right? The other thing we have to keep in mind is that these tiles have odd repetitions to them. So if we zoom way in, and I'm going to take a screenshot here, take a raw screenshot, I can't remember which is which. We'll take a look at those in just a minute. See the green right here, green right here. So we want to be able to figure out, oh, and is that a stone? I don't have a zoom on. We also want to be able to figure out, okay, here's that part of the wall. So what is different between these different tiles? Now this right here corresponds to this. So that's 1 unit, right? There's 1 unit between that wall and the end of that wall. So this tile is either entirely enclosed in this, or there is supplemental information included in our wall information, okay? Or at least that's what I think is the case. Now that may or may not be the case really, because if we look here, there's 1, 2, 3, 4 maybe, but we've only got 1, 2, 3 before we get to the edge. So what do? Let's pause the emulation and let's take a look at this file in its raw values. Oh boy, looks like I've got a dependency issue somewhere, but we can deal with that later. All right. I'm going to set up my Jupyter environment in this other window. So this is the dispersing. This is my Python library that I use for accessing these files. So let's take a look at this. We've got ts.levels. All right, so these are all my level maps. So let's take a look at levels 0. Here is my level map. So we'll call that L0. Now L0 has a number of different properties to it. I've got wrappers in front of my level asset. The level asset is directly from Kaitai struct. So if we look at level asset, this maps onto this. So I should then be able to access file header. So let's do I've got height, width, what do I call it? Looks like, oh, yeah, the file header is for the entire thing. We actually want properties. So here, properties. So L0 properties. Okay. Now, if we look at this one, remember our properties has wall tiles, floor special tiles, gate tiles, key switches, door tiles, wall decor, wall decor, wall decor, wall overlay, blank, unknown 12, big wooden thing, big boulder, and blank 15. So let's, oh, you know what, let me get rid of this. Okay. Let's take a look at all of these things. Okay, so oh, is that what's contained in sequence fields? Wouldn't that be nice? Ha, it is. Awesome. Okay, so for field in level sequence fields, v equals right, so now for every single one, for level in ts.levels, let's go ahead and construct our data frame here just so that we can see it. For v in, for field in v, v field dot append get attr level dot level asset dot properties field. Df equals pd dot data frame. Now this is probably gonna mess up somehow. Cool. So now we've got our floor tiles and all that stuff. So we can see all the different ways that these break down. So make sure nothing's going on. Okay. So let's take a look at this. Let's group this. Let's do unique. You're going to see me mess around. Yeah, of course. df. No, I don't want to do that. You're going to see me mess around with pandas. I'm really not the best at pandas. Yeah, I don't think that's going to work. All right, so let's take a look at df0. Okay, so this has wall tiles 44, floor tiles 24, floor special tiles 33, gate tiles 18, key switches, door tiles. Now, I have actually already done a whole bunch of work to get the sprites working nicely. So let's take a look at that. Yeah, okay. So this is tile info. Let's do so this is what we find at 1.6. Now, this is where it gets a little bit fun. That's up here. But up here, you can't get to without the secret code. So if you say Zebu to the first guy, it's like a debug cheat code or whatever. He tosses you up there, gives you a ton of stuff. So that's how we get up there. You see, these are the items that are on that tile. Okay, now if we actually look at the underlying stuff, tiles 1.6, it's tile type 27. Now, let's go back because we are getting ahead of ourselves. We will start here, right? We start right there. So let's see if we can figure this out. Now, what I've done here is I've overlaid the integer numbers that correspond to each tile. Okay? If we look at L0, no, that's just what it displays there. If we look at map, now if we turn this into a NumPy array, nope. Yeah, we do that, it's flat, but we can turn that into L0.height level, no, just properties.height, L0 properties width. Level asset.properties. Nope, it's just levels asset.height. Yeah. Okay. So this is what it looks like. That's what ends up getting turned into the other item. So Let's see. L0 map is equal to that. So let's do for line and L0 map print dot join line. Dot toList. I feel like I've done this about 10,000 times and I can never remember exactly what I called it when I implemented it. So, level map. There's terrain sprites, tile info. Oh yeah, terrain sprites. This is what I think the terrain sprites are. So this starts with the offset of the wall tiles, and it goes all the way up to 29. There are 29 wall tiles for each level. The wall corners, there are only 2. I'm sorry, there are 30 wall tiles. Floor tiles, you'll see that there are actually 8, but I think it's slightly different than that, and we'll get to that in a moment because I think these are quarter tiles. We've got gate tiles, key switches, door tiles. This is complicated. Note here, and this is really key, these are composed of 3 tiles total. Okay, so you've got your one side facing door, 2, 3, 1, 2, 3. Okay, so they face different ways, but there are a total of 3 that make each one up. Okay, unknown, I don't remember why these aren't just doors. The big wooden thing is just 1. The big boulder, that changes based on the level, and it rolls. And we've got wall decor. Now you'll note here, I didn't get all the sprites right. Some of the colors are wrong. Nowhere is that more clear than in the floor tiles. Like here, that should be green. I don't know what color that's supposed to be, which makes it a little bit tricky. And then there's the wall overlay. All right, so the wall overlay, we've got 10 total options for. All right, so I think this is tile ID 0 and this is tile ID 1. Note that I had to do some aspect ratio conversion, but we'll get to that, or actually we probably won't talk about that very much. Okay. Let me pull up my links here. So, I'm going to bring over here. So, L0 map.shape, okay, 18 by 26. So let's print it out with the actual values for row in L0 map.shape 0. We'll do that inside a range. Okay. For call in range L0 map.shape 1. Okay. Now what we'll do is we will print F, and then actually I can probably get rid of that second iteration, but we'll get to that. Print F row colon 03D space. Now what's the argument to this? Yeah, that's right, I'm a late adopter. End equals nothing. Okay, oh, yeah, there we go. So now for each column in it, we will do print F L0. First, at the very top, we will do print 1, 2, 3, 4, end equals that, and then for I in range L0 map.shape 1, this will be our header, print F I colon 03D space end equals that. Now I could also just do the end. You know what? No, it's the same thing. Okay. All right. so we get that, and now print L0, L0 map row call colon 0 colon space 3D. And actually, I probably want these to be space 3D as well. Okay, end equals that. Oh, right. Print. Now, I'm sure there's a better way to do this. Note here also, apparently, I need another space. That still didn't do it. Dang it. Ugh. Gotta say, there's probably I'm doing like a bunch of rookie mistakes. Starts getting messy when I do that. I saw David Bowie play this song on David Letterman right after the album came out. Dead Man Walking, and it really rocked my world. I got really into it, had to listen to the album. I was watching a fair bit of Letterman back then. I remember seeing someone who's rather famous now on there promoting something. Anyway, better not get into that. Is this it? Should I just pump this up to 4? There we go. That sort of did it, I guess. Why is this? Oh, because it's like left align versus right align or something, and then there's this. There we go. That did it. All right, so I am actually going to copy this. I've got a you can't see, but I've got my main Obsidian window open in another terminal, or in another screen, and I'm gonna copy that into it so that I've got it for later. Okay, so this is our upper left area. This is right around where we start. So let's take a look at this. If L0 map row call equals 255, print I need to continue as well. There we go. So we still have it all. I'm going to quick copy that into okay, so 27, 27, 27, 28. All right, so let's go back here and see what we can see. So we would expect there would be a slightly different one. Over here. Oh, actually, maybe there's one up here we can see. So 27, 28, 28. So that'd be up here. Ooh, look, there's a little bit of green stuff there, green stuff there. So we got to figure out where the boundaries are. Down here is 28. Up here is 28, 28, 27, 28. So looks like we've got ourselves an idea. Okay. Now back here, that's what I already did. So I've got that information going. What's not immediately clear to me, of course, is how do the walls factor into all of this. So if we take a look here, and I will pause emulation, bring this back over here. If we go over here, I think 28, 27, 27. But we need to figure out where the bounds are. Now, I worked on this and I came up with this as an idea for the bounds. But that was largely because of just how I thought the tiles might overlap. Okay? And that doesn't totally work because here, we've got 5, 27, 27, 27, all that stuff. So let's go back. Let's see if we can figure any of this out. Because we really want to get these tiles rendering, right? So wall tiles, nope, floor tiles. So we have 1, 2, 3, we have a total of 8, all right? And how many unique tiles do we think we have in this? So let's make this into a function. I'm actually just going to go ahead and put it in here. You'll note I've got a bunch of other stuff here. Print numpy array self. Okay. Now let me copy this. Oh, I'm on main. Okay. Array equals self. No. Map array equals self dot level asset. Actually, hold on. Is there one already here that I've got that? Self dot tiles. No. Oh, no, I already have it. Okay. Could have done that in here. Self.tiles. Now this, oh yeah, that's right. This song takes a long time to end. Okay. So everywhere this says L0 map, we'll say self.tiles. Now I should be able to level rendering. We're gonna eventually get to Pi Arcade. Let's run all our cells. Okay. Yeah. L0 dot print numpy array. There we go. So let's do that for another one of them. And we can take a look at what we think the different tiles are. Here you'll see this is 36. Ooh, 36. I wonder what's going on with that. Now in my notes from ages and ages ago, I decided that that was likely okay, so here's what I came up with once upon a time. 36 is a teleporter, which is typically special tile 5. Okay, and what I thought was that 24, 25, 26, 27, 28, 29, 30 were floor tiles 1 through, 1 through 7. 1, 2, 3, 4, 5, 6, 7. Oh, no, floor tile 0 as well, 23. So I'm not sure that actually tracks. And I think the reason that I'm not sure that it tracks is because I think we need to look at this as though the tile squares are bigger than I was originally thinking. So each one of these is not sufficient. Each one of these floor tiles is not sufficient. If we look here, this is actually tile ID 0, we thought. Looks like this, okay? Here it draws the wall over the floor. Wall tile 0 is actually 2. Wall tile 15. So let's take a look at our wall tiles as a start. So we've got 0, looks like the top corner. This looks like a non-corner. This is another corner. This is down the other side, and then that's 4. So if we, here, I'm going to draw this out here. Looks to me like we have something like what? Oops. Used to Blender keystrokes at this point. Here, let's zoom out. We'll go over here. So I think our tiles look something like this. Okay, now we'll make it totally black. Wow, it is. Am I just way zoomed out? What's the deal here? Oh yeah, opacity. Let's make it fully. So we have several different directions here. Right? We've got that one, and then we've got um, let's. I want to duplicate this. There we go. And then let's rotate this. Well, let's just flip the horizontal. Okay. And so that corresponds to 1 on the left and 3. So 1, 3. Okay. And then 0. Okay, something like that. And note that it's at the bottom of the frame. And then flip this vertically. And note that it is, let's see, that's, oh no, we've got corners as well. We've got a whole bunch. Really, I should just be importing these images in. Maybe I can do that. Yeah, okay, I'll do that. So let's, we'll do this real quick. Okay. Now we've got a lot, so it will take me a sec, but this is going to help us with figuring this out. That's 5. Here's 6. 7. 8. 9. 10. 11. 12. 14. Now, I did figure a bunch of this out in the past, so this is all sort of a setup to me doing this, but I think it'll be worth it. In just a moment, I will arrange and distribute these so that they look nice, and then we'll talk about the different ways that these tiles get combined. One really cool thing that we're going to see is that what the summoning does in some of these situations is it combines things with bit fields and whatnot, and then implicit combinations. Interesting. I actually had not noticed that 21 and 22 were identical in the past. Maybe they're not, and I'm just not rendering something in the color palette, but I think once again what we're seeing is that our tiles on screen are composed of multiple items concatenated together vertically. And here's our last one. Okay. No, here's our last one. So we have a total of 30. Okay, now let's zoom out. Oh boy, look at that drift. Okay, let's align them all and distribute them. Okay. I also really think they should be a little bit bigger than they are. Let's see, can I... No, not necessarily. Okay. Okay, so we've got this set up. Now let's figure out how do all these different things come together nicely. So if we look back here, we've got our wall, 0, 1, 2, so here's 0. And actually, let's go back here to this. So here's 0. Okay, 0. And that matches up perfectly. Yeah, you know what? I really think I messed up by... All right, so now... So if I put this one down here, and I just select those, what happens if I distribute them? Actually, let's group them. Now let's align these to the same baseline. What? There we go. All right, now let's align these to the baseline. Okay. Let's align those to the baseline. Okay. Let's get all of those. Now we'll distribute them vertically. Let's align them horizontally. And let's group them. Okay. Now I should be able to group these two as well. Okay. So we've got 0 right there. That's what we would expect. But note that it doesn't sufficiently cover it. Okay. It gives us 0, but we also need stuff there. Now, if we look here, go 0, 1, 1, 1, 2. So let's take a look at 1. There's 1, 1, 1, and then 2. Let's unpause this. Or actually, let's look back over here. 3, 3, 5. So 3, 3, 5. So 5 right there. Okay, that looks about right. But the thing is, we don't have the bottom. So what is the bottom that we're looking for here? It's got to be a little bit of a corner. And I think it's 20. So 5 and 20 are different. Is it 20? Yeah, I think it's 20. Okay, and then up here, what does this corner look like? I think it's 25. So how do we reconcile getting these numbers? One way that we could do this is we could assume that all of our items have some sort of fixed offset to their wall. So that means that 0 and 25 would always be the same, right? 0 and 25 would always do it, but that doesn't necessarily work if 0 shows up in any other contexts, right? 5 and this one, oh my. Let's do this. Got a first time chat. That is spam. Okay, so let's go back here. We've got 0 there, 0 there as well. So, two ways we can do this. We can assume that it's either encoded here or that it's encoded in one of these. Now, this doesn't look like it encodes it because we get 27 along all of these, whereas we would expect that at the corner we would get something different. So it's probably something very specific to the way that 0 is encoded. So 0 seems to match up with 20. I'm sorry, no, 0 matches up with 25. Here, 1, which we think is that one, seems to match up with 16, maybe? Oh, wait, 15. Are 15 and 25 the same? Oh, dang. What if I've been double counting this and that's why there have been problems? How did I do that? I wonder if that's just the whole thing. Okay, well, let's take a look. Let's try just offsetting by okay, 0, and let's see if we offset it by 15. Well, let's take a look at that one. Okay. Actually, that doesn't it does kind of look right. Okay. Now, 1, and 16. There we go. Also looks kind of right. Now let's start drawing this. Missing a piece right there, huh? All right, we will get to that. We look at this and we see there is 1, 2, 3, 4, 5. So let's do another one of these. have to come back to that. So that's 2. 3. So we've got 1, 2, 3, and now it goes to 2. And let's try the offset of 15, so 17. Let's see if that actually does look right. I'm not sure that it will. Okay, so I'm going to do a little bit of aligning these just to try to minimize the difference here between the image from the level and what I'm comparing against. Okay, so this seems a little bit strange, but let's pull this back over here. Oh, yeah, let's choose a new album while we're at it. I actually don't think I'm going to be on too much longer. Actually, maybe I will be. We'll see. Let's get a new album to listen to. How about Icky Thump? It's a good album. Let's resume here. Okay. Come on. Yeah, the resuming from pausing is always a little tricky. Okay. Let's see if I can get it. Yeah, there we go. So let's pause now. Let's take a look here. All right, this is a little odd. It does kind of match it, but we're missing something, right? So we already did the offset by 15. Let's see what happens if we do a different offset. Let's see if we can match up what we're missing there. Okay, so something that looks like it does this, right? That would match up right there. Nothing immediately jumps out. That's odd. So what goes there, there, and then I assume this will be, you know, the, let's see, 3. Yeah, and then we'll have something that takes that corner and then gets painted over. All right, how did I address this in the past? Let's see, did I come up with any ideas? Yeah, so I think at one point what I tried doing was I tried rotating them. But if we assume that we've got 30 to play with, 0 to 15, now this one is a 1. Let's try 11. No. Nope. That definitely does not do it. So if we look, and it's hard to zoom way in on this, but it looks like there we've got a little bit of gray and a horizontal line. So let's see if we can find that. Let's try it with 23. And let's try flipping it. No. Although that might fit there, I'm not convinced. Alright, so seem to be further away than we were at the start, huh? Anyhow, we've got these tiles, got these. So let's try. Let's do this a little more systematically, shall we? We assert that tile 1 is 3 items, one on top of the other. Okay, so let's do this here. Import and let's see. From PIL import image. Now we will have image equals image.new RGBA, and the shape is going to be, see, these are 32 by 16 by 16. Width will be 32. Height will be 48. If we look at it, looks like that. Now what we'll do is we will say image dot alpha composite. And let's see, how do we get this wall tile? Okay. All right, so image alpha composite. We will do this with definition make image A, B, and C. Okay. IMA equals L0.trainSprites.getWallSprite A. IMB is L0 terrain sprites get wall sprite B. IMC is L0 terrain sprites.get wall sprite C. We will alpha composite A at 0 and start will be 16, I think. We'll have to check on that. No, 0, yeah, 0, comma 16. No, this should be 0, 16, 32, B, C. And then we return it. Okay, so make image 0. We think it is 0 with an offset of 15. Let's try 11. Oh, what? Did I already solve this problem? L0 terrain sprites get wall sprite 0. I did. Dang it. But now, oh, no, I don't think I did, because I think, yeah, it doesn't work for 1. Yeah, they're still missing 1. So, let's see. We don't want get wall sprite, we want terrain sprites wall tiles dot frames yeah. Int object has no attribute size. What? Oh. Source has to be 0, 0. no, I actually want this. Alright, so something is messed up with my images. .32 by 16. If length of source is equal to 2, overlay crop box is tuple of source plus IM size. Oh, of course. IM A, IM B. Alright, now I really want to display this way bigger. Let's resize it. 32 times 8, 48 times 8, image dot nearest. Okay, so that's what that looks like, but we didn't want that. All right, so let's do 1, 16, 11. We actually want this last one to be first, right? So let's do 11, 1, 16. Now we're getting somewhere. Okay, so let's just try this with every single possible value here. Now, I know it's going to be bad, but let's just try it. So, for v in range, 30. Now we'll display make image v116. No, I actually want that to be just v. All right, nope, nope, no, 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 nope. Although that one looks a little closer. Nope, nope, no. That one maybe if it were flipped. That one maybe if it were flipped. Probably not if it were flipped. That one maybe if it were flipped. Some of these are duplicates, I think. Alright, so now let's try flipping them. But actually we probably should look at let's take a look at these frames, shall we? L0.terrain, because there might be information encoded in there. Yeah, we've got that. Okay. Let's take a look at our record. So this is a resource record. Let's take a look at our header. We've got a bunch of fields here that we don't know what they mean. Field 1, I believe that's the number of frames. Field 2, I think that's the size. know what? Let's just see. 1056. Let's go back here to we're not going to do saves. We're going to do resource. We'll do 1056. Header. Field 2, that should be height. Yeah. Width is 32. Count 30, that's the number of frames. Field 4, 254. Algorithm is 3, and then the contents. Pretty sure that that is unpacking. Yeah, this does not. Yeah, okay, so there's no additional information there. Okay. All right, let's try flipping the this one. Let's transpose it. We think it should be the first one. img.transpose, or imga transpose image dot flip top bottom. Now the one we liked, maybe that one, maybe this one. No, see the edge there. Let's try 28. And what did we say this is? IMA. What? Oh, it returns a new one. Okay. So let's just put that there. Not too bad. Let's try rotating it. Oh, let's try flipping it both top, bottom, and left, right. I might be able to do that all in one, but wait, what? That should have done something. Oh no, it did. Okay. So that's not what I was expecting. Now I suppose the other possibility that it's a rotation. Let's rotate 180. I guess flipping and then flipping is the same thing. So I suppose the other possibility is that the tiles are drawn like this, and then one to the right. So let's change this to 32, and this to 48. And so we will draw the top one. We'll do that one at 0, that one at 16. And then for the top one, we'll start at 0, but we'll move 16 to the, move 32 to the right. And that should be 64. Obviously, I did something wrong here. Oh, right. So here, this is what we had before. But if we assume that then we have to have something here, that would work. But I don't like that solution. I really like the idea of it being, here, let's see, wall corners. Okay. Perfect. Is it? Not quite, actually. That actually does not look that great. Now, it's possible that, well, here, let's try it with wall corners. Okay. Wall corners. So this would then be 32 by 48, and the top one will be wall corners, frames, yep. And this will be 0, 0, 0, 16, 0, 32. Oh, they're only half height, aren't they? So instead of 48, this should be 40? No. L0, terrain sprites, wall corners, frames, 0. 8. All right. So this should be 40. Should be 8. And that should be 40. No. 24. Perfect. All right. So our walls, and let me write all this down. my notes. Okay, let me bring this over here. So, let's copy our Jupyter code in here. So now what I should be able to do is I should be able to render all the walls. I think I might have enough time to experiment with that. So, if I'm doing my math right, we should be able to create a new image. It'll be offset by 32. So we will do 32. Let's render 3. Let's render 4. 32 times 4. And then we need an offset of 8. So 8 plus 16 times 4. Okay. So we will do make image first is equal to make image. Do we want a corner for this? You know, maybe we do. No, guess we don't. All right, so make an image. We will do. We'll just say 0, 1, 0, 0, 15. Second is make image 0, 1, 16. So now we just paste these all in a row. So image dot alpha composite. The first one we will offset at 0. First. That did not do it. Oh, because it's not doing the... Dang it. Alright, so we want this to be size 8. Alright, so... Okay, so there's our corner. And I think for the corners, we'll just assume that they don't have a thing, but we will get to that in a minute. Okay, so now image dot alpha composite. And it's also possible that the others will overdraw it, so we'll see that in a second. Second, and we offset this by 16, no, they're 32 wide, so 32 down, 16 across. No, that was, of course, 32 times 8. 16 times 8. Well, this is looking quite promising. So I think the special case here is if it doesn't have, if it's a corner, so if this one would not have a corner. So if it's 0, 2, 4, actually, you know what? We'll just try it as is. Let's try rendering this. This is a little funny to me, but so it might still not be right. Oh, you know what? I've got the, yeah, okay. So the corner there is not operative. This is starting to make sense. And I think I'm getting it. So, this is actually much further than I've gotten in the past. Let's go back and revisit my code that I used to attempt to render this once upon a time. What I was trying to do was I tried this create map. But I had that corner missing. Yeah, I was kind of confused with this, but now I think I'm getting it. So there are various different things you can do, like use a tiled map editor. But instead, what I'm going to try doing is constructing these sprites. So let's do this. And actually, let's gatekeep all of these. Because it's possible that we will end up in a situation where we need to drop the bottom off as well. Okay, so there we've got that. So now let's try make image. And now corner -1, 0, 15 gives us that. Okay, now let's try it for down here. If we look at our map, that's 2. So let's try just using the same offsets. Make image -1, 2, 16, 17. interestingly, I think there we do need the corner. Okay. So now let's try it with the walls that are going the other way. So these. That's 3. Let's just try it. Make image 1, I think, 3, 18. Nope. Leave you alone now. Okay, what if we slide that over? Let's just toss that on here. L0 terrain sprites, wall corners, 0 dot frames, 0 dot width. It's half width. Awesome. So we need to offset it in the X. We need to offset the corner in the X if B, let's see here, it's 2. Let's see. Oh, let's do it with the rest first. 5. Looks like it's just 5. No, yeah. There are 4 different corners. Yeah, in some areas you'll get others, but 4 and 5 now still. Okay. That one looks like it should go all the way over. Okay. And that one too. Okay, so let's do bin of. I guess we'll just say if it's greater than 2. If B is greater than 2, offset equals 16. Else offset equals 0. So X offset. So now 5. There's got to be some clever way to do a bit field to figure out that you need both or something like that. But let's take a look at 4, see if it works for 4. Yeah, it seems to work for 4. 5, though. And what's 6? Yeah. Okay. You know what? What about 3? We didn't look at 3, did we? So 5 needs. All right, let's just keep doing this. So the corner that goes to the left is always offset. Yeah, so, okay. I think I'm figuring it out. We have an offset to the left. And when that offset to the left is, okay, let's do 6. Let's get rid of that, and we'll say left equals false, right equals false. So we will have these two corners for ourselves. Get rid of A. If left, alpha composite, frames 0 at 0, 0. If right, do the same thing, but offset it. What did I set this to? 16? So now we'll get rid of C. This will be our wall tile ID. This will be our wall tile ID plus 15. Okay. So now let's make our image for our wall tile ID 1. There we go. All right. Make image for 0, false, false. Perfect. Make image 0, 2, true, false. Make image 3, and this one we want false, true. Yep. Now we'll make an image 4, false, true. All right. So what we're going to do in just a minute is our final one is 29. So we get how many unique do we have here? I can't quite remember. We're going to figure out, I think there's a bit operator we can figure out here. So 3, 4, false, true. Okay, make image 5, true, false. No, true, true. But bang, because you made up the law. Nope, that one should be false, true. Okay, so what we're going to do as soon as we get through these is we're going to take a look at our bitwise operators, or at our bit encodings, and see if we can come up with some rule that we can just apply to it. And I think that's going to work. That one looks a little bit weird. I think actually I'm not sure about that one. Let's move on to 11. Huh. Yeah, that one definitely needs it. So we'll come up with our truth table in just a minute. I think the next one is our last, 14. And it looks like that one should be false, false. Because if I do make image 15, list index out of range. Okay, so let's come up with a new text file just so that I can take notes on this. Put it over here. All right, 0, 0, 0, 1, 1, 0, 2, 1, 0, 3, 0, 1, 4, 0, 1, 5, 1, 1, 6, 1, 0. And what we're going to do is we're going to see if this is something we can draw out of it. If there's like a pattern, and it kind of looks like there is. It looks a little like gray code, but no, I mean, of course it would. Everything would look like gray code at this point. 8 is 1, 1. 9 is 1, 1. 11 is 1, 0. 12, 0, 0. 13, 0, 1. 14, 0, 0. Okay. So, what do we have? So all zeros, 0, 12, 14. All ones, 5, 8, 9. 1, 0. 1, 2, 6, 11. 0, 1. 3, 4, 7, 13. Okay, so let's take a look at these. Bin, let's see, how do we do this? Is this H, F, 12, 0, 8, H? Is that right? All right. All right. I'm getting so close to getting this done, though. Oops. Okay. I'm gonna have to hop off in just a minute, but this has been extremely productive for me, at least, and it's been a good way. Everything else going on to really just focus on something fun. I've been having a hard time with fun stuff lately. Let's take a look at all of our ones. So bin of 5. Bin 8. My hypothesis is that there is some flag here, but it's also possible that there just needs to be some sort of storage of them, I guess. So, or some like manual specification. that's a bit odd. 5 seems a little out. All right, let me put this in here where we've got our get wall sprite. We've got wall ID, aspect ratio. We are going to concatenate vertically the two PIL images. Let's get this information from here. So we will concatenate them vertically, but they are going to be wall tiles. Oh, that's nice. Okay. Now the next thing we're going to do is we want to concatenate these blank image dot new RGBA. Wow, it's really going through some songs here. Width 16, height 8. Okay, so now what we will do is we will concatenate horizontally based on our truth table. So let's okay. So corner table, there we go. Now here, if corner table wall ID, we'll do left, right equals corner table wall ID. If left, oh, and here let's dang it. This should be 1. 0 for false. Okay, and now if left, we will concatenate else. If left, left tile equals self wall corners dot frames 0. If right, so now we tile is equal to concat vertical, concat horizontal, left tile, right tile, tile. There we go. So now I should be able to go back here going to do a whole bunch of stuff. And then what I'm going to do here to finish up the stream, dash B wall tiles. It broke. Oh, no, it's not. Get wall sprite 0. Corner table is not defined. Ugh. Let's check this one now before I sputter out. Get wall sprite, looks like it's right. Okay. Yeah, alright, now let me commit this. Fix wall tile sprite getting. Create a PR. As seen on Twitch. Okay. Oh no. We'll recover it. Let's merge it. And just like that, let me say goodbye. Thank you for joining me. I thought I would get to Python Arcade today, but it turns out I did not. So I did fix the tiles though, and actually I'm reasonably certain this will set me up nicely to fix up the overall isometric rendering. So have a good rest of your weekend.